Greetings. Welcome to Introduction to SQL for Excel Users, Part 10, Basic CTEs. I'm your instructor, Dave Langer. So I'm starting this tutorial in SQL Server Management Studio, SSMS, and in particular, we've got a query here from Part 9 of this tutorial series, and this query is designed to answer a specific question. For each date key, which shift had the highest number of calls? Now, if I just go ahead and run this real quick, we can see the output that we saw last time in part 9 of the tutorial, where every row that has a row num of 1 is the shift by date key that has the highest number of calls. Because you can see here are 4 date keys that are all the same, and you can see all the calls, and notice that row number 1 is always the one with the most calls. We learned about basic windows. We learned about how the mighty row num can help us answer a lot of really interesting questions. And here's one. Now, the only problem with all of this is that we get a bunch of extraneous stuff. We get row 2, 3, and 4. And quite frankly, we don't care about those rows. They are extraneous to answering the question. So what we'd really like to do is narrow down the result set here to only those rows that have a row num of 1. So you guys have been taking this tutorial series. You're like, you know what? That's a filter. And when you filter in SQL, you use the where clause. So Dave, I'm just going to go ahead and add a where clause to that. And you know what? That is a reasonable strategy. Now on the surface, you would think it would work. Now, of course, what you can see right away here as I scroll down to this query version of the query where I've added the where clause is you're getting a red squiggly of death, right? It's saying it's an invalid column name. SSMS is saying, Dave, this is not kosher, man. This is not good. So if you run it, you're going to get exactly the same error. It's going to say the invalid column name is row num. I don't understand what row num is, but you're like, wait a second. Row num. It's right here. Well, yeah, here's the problem. You have to remember the conceptual processing order of SQL, and then this red squiggly of death right here makes a lot of sense. So let's walk through it. Conceptually, given the amount of SQL we have now under our belt, this is how the query actually gets processed. First thing it does is SQL says, Dave, where do you want to pull the data from? Oh, okay. You want to grab all the rows, as far as I know right now, from fact call center. And you also want to alias the actual table FCC while you do that. That's totally cool. No problem. Great. And then next up, it says, Dave's also specified a where clause. He's also specified that he wants to filter down the rows. Here's the problem, right? Where comes next. But this doesn't get created. Row num doesn't get created until the select list is actually executed. So row number, if you want to think of it this way, is quote unquote created after the where clause is processed. And this is why you have a problem. SQL says, I don't know what row number is because you haven't actually built row number yet. You do that last. Well, actually, order by is last, but third step, right? First step, this. Second step, this. Third step, the select list. And then fourth step, the order by. This is not last, unfortunately. Sorry about that. It is actually third in the line of processing, but it is still after the where clause. So what this tells us is, and I've mentioned this in a previous tutorial, this idea of virtual tables. Virtual tables are extremely important. They matter a ton in SQL, and this is an example of it. This whole query, as I mentioned before, produces a virtual table, but you can't actually filter on a virtual table directly because it doesn't exist at the time that the where clause is actually performed. It only works on real, quote unquote, real tables. In fact, call center is a real table because you can go over here to the database and you can take a look at it and you can see here is fact call center right here. So you can filter on it because it is real, because you select data from it and then you filter it and then you execute the select list. I'm going to flip over to Excel to talk a little bit more about virtual tables to give you some sort of intuition of what the idea is using Excel, and also to illustrate why this right here does not work. All right, I'm in Excel, and this is for the workbook the Excel file for part 10 of the series. And what you'll notice here is I've got a table. I've got the call center table in Excel. And if I go to the table design section of the ribbon, you can see here it has a name. Now, the easiest way to think about this conceptually, to map Excel ideas and knowledge to SQL, is this. This call center table has been saved to the hard drive of my computer as SQL for Excel Users Part 10, right? That's the file. And inside that file is a worksheet. And inside that worksheet is a table. Since it's been saved to my hard drive, it's real, quote unquote, because I could close Excel down and reopen it up and the data would all still be there because I've saved it permanently, quote unquote, to my hard drive of my computer. So this is a real table. This is analogous to Fact Call Center that we saw in SSMS. Literally behind the scenes, SQL Server has a file on the hard drive of my computer where the data for Fact Call Center has been saved. That's so when I reboot my machine and I restart SQL Server, it can load that data back up. And it's been persisted. It's quote unquote real. A real table, quote unquote, in SQL Server is much like a table in an Excel workbook that has been saved to the disk. You can reconstitute it. You can reboot your machine and reload it. Using Excel as a conceptual framework for understanding SQL, a virtual table is akin to what I'm about ready to do, which is if I make a copy, create a copy, move it to the end. So we have call center 2 right here, okay? So I'll make this copy of call center real quick. All right, excellent, and hit enter. Now here's the thing. Notice that first thing that Excel does is it says, okay, cool, Dave, I will go ahead and copy this worksheet. It includes a table, right? The original table, the real one, quote unquote, the one that's been saved to disk is called call center. So I can't reuse that name. So I will go ahead and create a copy of the table and call it call center 3. Now here's the thing. I haven't saved this to disk yet. So if I close this down or if my laptop crashed or whatever, this copy of call center would be lost. It's not real yet, quote unquote. It's not persisted. It exists insofar as it's in memory and it's in Excel, but until it gets saved, it's not real. It's like a virtual table. This is how SQL virtual tables work. You run a query in SSMS and it gets created in memory, but it's not saved anywhere. It's not saved anywhere to a hard drive, so it's not quote unquote real yet. And that's the difference. Now, one of the big differences between working with a virtual table, quote unquote, in Excel versus in SQL is this right here. Even though this table is not real yet, this copy of call center, or more specifically this call center 3 table, is not real yet because I haven't saved it to the hard drive of my computer, it still has a name. So even if I never saved this workbook, I could actually manipulate data in this table using the name call center 3 because Excel always gives a name to every table, whether it's quote unquote real, saved to the hard drive, or it's quote unquote virtual. It exists in the workbook memory while Excel is running until I save it. Either way, since it has a name, I can address it. Now in SQL, and this is very important, in SQL, virtual tables by default have no name. So you have no way to work with them because they are transient constructs. They are literally just ephemeral collections of data that are produced by SSMS, spit out to the results window, and that's it. If you close SSMS down, you lose that data until you rerun the query. So you can't actually do that. You can't do much with virtual tables as such. So what we would really, really like, what would be really super awesome, is the ability to work with a virtual table, but give it a name. Give it a name so that we can then work with it. So for example, we could use the mighty row number function and say, look, I want you to create a virtual table with all these row numbers. I can give that virtual table a name, and then once it has a name, I can use a where clause on it and say, oh yeah, out of that virtual table called foo, let's say, give me all of the foo row nums that are equal to 1. And the good news is That thing exists in SQL. It's called a common table expression, or a CTE. And CTEs are awesome. So I'm going to flip back over to SSMS so we can start talking about CTEs and we can see them in action. All right, back in SSMS. And what you can see here is some commented pseudocode. If you're not familiar with the term pseudocode, it basically is a textual representation of code, but it isn't actually legit, and you use it essentially to communicate ideas. So this is a poor man's version of pseudocode invented by yours truly on the fly. What a CTE does at base is allow you to define two things. First and foremost, it allows you to define an outer query. And you can see here, this part of the template is what's known as the outer query. And how you know it's part of the outer query or is the outer query is because it's not within these parentheses. Okay, so we have an outer query. What's great is that a CTE then allows you to define what's known as an inner query. So the inner query exists right here inside of the with keyword. Now this is great. What this tells SQL is this: hey SQL, I am going to create a query and it's going to produce a virtual table. And I want to give that virtual table a name. And that is the name right here. So you say, hey SQL, with this name defined as this, create a named virtual table. And this inner query gets executed before the outer query and produces a virtual table that then has this name. And then anything that's in that virtual table that's produced by this part of the CTE is now accessible to the outer query. So the outer query can reference the inner query. And this is super powerful stuff. This allows you to do all kinds of really interesting things. And by the way, in the real world, you use CTEs all the time, especially when you're using SQL primarily from an analytics perspective. You use CTEs all the time. And you do it for a couple of reasons. One, it allows you to do things that you couldn't normally do. For example, we'll see here in a second, we'll use row number, and we'll want to pull just the records from the inner query where row num is equal to 1. CTs allow us to do that. And two, and this happens to even be even more important over the long term, CTEs allow you to structure your code, your SQL code, in such a way that it's actually intelligible. It's actually something that someone other than you could read the query and actually understand what's going on. Or, interestingly enough, if you ever write a query, save it off to your hard drive and come back maybe 6 months later, if you've structured your code nicely with CTEs, you can actually figure out what the hell you were thinking when you wrote the original query. Trust me, I'm speaking from experience on this. So CTEs are awesome sauce. You use them all the time. So this template is a little bit abstract. It's a little bit crisper if we actually pull up some actual code here. Okay. So here we have a CTE. So this is super important, by the way. We talked a little bit about window functions last time, and we're using the mighty row number window function right now. Window functions are extremely, extremely useful in analytics. Window functions in combination with CTEs are like chocolate and peanut butter. They are better together. You're going to use these all the time. Let me show you what I mean by that. So let's go ahead and conceptually unpack this SQL one step at a time. So first up, SQL says, oh, Dave's got a with here. Okay, cool. He wants to use a CTE. So he's going to create a inner query, and he wants to use the name daily shifts by calls. He wants to use that as the name, and he wants to define the virtual table as follows. And everything within these parentheses here is the SQL that defines the virtual table that will be named daily shifts by calls. So that's the new part of the syntax, but it's not super difficult. With name as a couple parentheses, and then you slap your SQL query inside of it. Boom. Now the SQL query that we have here, you'll notice is totally legit. We could just run it by itself, and we get back what we saw before, because this is the same exact query that we had before. Row nums by date keys, everything's great. Sweet. So this is the inner query. Now that we've given it a name, we can actually write an outer query using the inner query. And here's how we do that. So first up, we tell SQL, hey, I want to pull all of the data from the virtual table, daily shifts by calls. That's what this says, right? The from. Works just the same as if I was pulling from a quote unquote real table. And I can even give it an alias, which I do, DSBC. So SQL says, wait, that's not actually in the real database anywhere. Oh, but it's right here. Cool. This is legit SQL. Dave, no problem. I will pull all the data from the virtual table called daily shifts by calls. And then I tell SQL, yep. And then the first thing I want you to do is I want you to filter. I want to apply a where clause to DSBC where row num is equal to 1. So get rid of the 2s and the 3s and the 4s and whatever else there might be. I only want the 1s. And SQL says, cool, no problemo. Then SQL says, Dave, what do you want out of the remaining rows that you get once the filter's applied? And I say, okay, I want the call center ID and the date key and the wage type, shift, and calls. And then I want you to order it. And SQL says, Dave, this is all totally legit. Go ahead and run it. Boom. And there you have it. Notice that I left row num off because now it's extraneous because these are all row num 1. I mean, it doesn't make sense to put it in there. Of course I could if I wanted to. Let's go ahead and do that real quick. dsbc.rownums. Notice how I get this automatic IntelliSense. It knows that row num is now part of daily shifts by calls. That's a big hint that I've written the code correctly. Okay, sweet. And I'm going to just run this again. And I get all the row nums back. But I think that's ugly, so I'm going to get rid of it. I don't like that. We can use these window functions, these extremely powerful window functions, and we can answer really interesting business questions. And when we wrap them in CTEs, right, we get this chocolate and peanut butter effect. We can now say, ha ha, I only want row number 1. Now, here's the cool thing. Now, I don't know if you would ever really need to do this in the real world, but oddly enough, if you decided, hey, I don't want the shift by date key that has the highest number of calls, I want the shift by date key that has the second highest number of calls, you can do that. Easy peasy, just like that. And you can run it again. And now you have by date key the shift with the second highest call volume. Now again, I know it's a totally contrived example and it's silly and you're probably not likely to do that in the real world, but it's pretty cool stuff, right? Nevertheless. Okay, but I'm going to get rid of that because that's just too much silliness for me. Okay, now here's what's really cool. Using the combinations of CTEs and row number, and there are other window functions available, and later in the tutorial we'll talk about some other ones. But row number is a super awesome one that I use all the time in the real world in my daily work. You can answer really super interesting questions like, what is the largest value of X in each window? Now in the previous query, or the query right here, we were looking at calls, but it could be any column that you're interested in. What is the oldest value of X in each window? What is the smallest value of X in each window? What is the newest value of X for each window? Now here's what's really cool. You don't actually necessarily have to write 4 separate queries to answer all of these questions. You can actually write one query with a CTE built in that actually pulls back all 4 of these things simultaneously. And I'm going to give you an example of what I mean by that. So what I've done here is I've just modified that previous CTE that we saw, and I added a little bit of magic here. I can call row number twice, and I can create one for the min and one for the max. Now notice all I have to do is I just have to change the sort order. Right? If I create a window over the date key and then order by calls in ascending order, so it goes lowest to the highest number of calls, row number 1 for this particular column that I'm creating, this min row number 1 would be the smallest number of calls. And we saw this already, which is we created a window over the date key, and we actually sorted these in descending order, which means row number 1 is now the highest call number. So this is really sweet. I just added the row numbers here just to show you what I'm talking about. So if I run this query in one fell swoop, I get back 2 pieces of interesting information. for each day, which shift is the minimum number of calls. You can see here, midnight, not surprisingly, is the lowest. And also, what is the max, right? But notice that the min and the max aren't necessarily the same. Here it's AM shift on this date key, but here it's PM1. But again, midnight is the smallest, and midnight is the smallest. But you get the idea. Right? This is great, powerful stuff. You can answer many, many super interesting business questions using the combination of window functions like the mighty row number in combination with common table expressions, CTEs. You're off to the races doing all kinds of wicked analytics. As we'll see later in the series, we can actually use window functions and CTEs to do in-database analytics at scale. We'll show how you can do what is known as an RFM, a recency frequency monetary analysis, directly in the database using SQL. We will also show how you can do a Pareto analysis or an 80-20 analysis inside the database at scale using window functions and CTEs. It's great, great stuff. Okay, that's it for this tutorial. Hopefully you're enjoying the series, you're getting use out of it. If so, please subscribe to the YouTube channel because I will be posting content regularly on this topic until it is completed. And until next time, stay healthy, and I wish you very happy data sleuthing.